Hi folks, welcome to part 3 of Related Rates, which is section 4.1 in your textbook. So we're going to take a look at this example right here. We have a 6-foot tall person who walks away from a 10-foot lamppost at a constant rate of 3 feet per second. What is the rate that the tip of the shadow moves away from the pole when the person is 10 feet away from the pole? And so what we're going to do here, now a diagram was provided, but I'm going to go ahead and take this diagram and I'm going to translate it into 2 separate triangles, because what we're going to try and work with here is the idea of similar triangles and how they help us when we look at related rates. Okay, so I'm going to draw the first triangle, which is going to be including the lamp post. So I know the lamp post is 10 feet tall, and I'm going to say that this distance on the bottom is not 10 plus x, but I'm going to call it y plus x. The reason why I'm not going to use the 10, so this is 10, and at the moment y is 10, is because y keeps changing as the person walks. So 10 is going to be a number that I plug in at some point down the road, but not right now. Okay, the other triangle I'm going to draw is going to be the one involving the person. So I have this 6-foot tall person, and at the moment the length of his shadow is x feet long. Okay, so what do we know about similar triangles? We can say that x over 6 is going to be equal to y plus x over 10. And really where we get that from is this is the base of that triangle, and this is the height of the triangle. And because they're similar triangles, we can set up that ratio. Now, before I take a derivative, I'm going to make this equation look a little bit easier. So what I'm going to do is I'm going to go ahead and multiply the 10 to the left-hand side and the 6 to the right-hand side. So I'll get 10x equals 6y plus 6x. And then I'm going to combine all my x's on one side, so I'll get 4x equals 6y. And I'm going to go ahead and solve for x. So x equals 6 over 4y, or I could say that is 3 over 2y. Okay, now this equation is going to be a little bit easier to find the derivative of. On the left-hand side, the derivative of x, it's not just 1 because I'm talking about related rates. I have to write it as dx dt. On the right-hand side, and we're going to use this simplified form, we can notice that the 3/2 is a constant, so that's going to stay in the front, and the derivative of y is going to be dy dt because I'm looking at the change in the in that distance over time. Okay, so let's go back to our problem and see what numbers we have. So it tells us that the person walks away from the lamppost at a constant rate of 3 feet per second. Now this 3 feet per second is the rate at which the distance between the person and the lamppost is changing. And so we can go ahead and plug in that 3. We'll get dx dt equals 3 over 2 times 3. Or we can say that dx dt equals 9 over 2 feet per second. Now this is actually just going to be part of our answer. This tells us how quickly the shadow, this is the rate of the shadow changing length. So shadow's rate. But what we want to know is the rate of this whole thing, the rate of y and the rate of x. So what we have to do is one last step. We're going to say that we want to find dy dt plus dx dt to get this rate of change right there. And when we do that, we're going to remember that our dy dt was 3 plus our dx dt we just found out is 9/2. And when we add those together, we're going to get 15/2 feet per second. Okay, so let me just zoom back out so you can see the whole thing before I move on to the next problem. Okay, example 6. So the base of a triangle is shrinking at a rate of 1 centimeter per minute. And the height of the triangle is increasing at a rate of 5 centimeters per minute. Find the rate at which the area of the triangle changes when the height is 22 centimeters and the base is 10 centimeters. So I'm going to go ahead and color code a little bit more here. Since I said the base is shrinking at 1 centimeter per minute, I'm also going to note the base is 10 centimeters in the same color. And since I know that the height of the triangle is increasing at a rate of 5 centimeters per minute, I'm going to go ahead and color code the height is 22 centimeters in green as well. So I think one of the things that's tricky about related rates is you have to know what equations to come up with. And a lot of times the clues are in the problem. And so over here I'll notice that we want to know about the area. So maybe what I should do, I'm going to draw a diagram, label some things, but I'm also going to write a formula for the area of a triangle. Okay? So let's start with our triangle. And I know that the height always has to be perpendicular to the base. And at this very moment, I know that the base, and let's call this B, the base is 10 centimeters. And I know that it is shrinking, so dB dt is a negative number. It's shrinking at a rate of 1 centimeter per minute. Now let me go to the height. Okay, so the height of my triangle. The height is currently 22 centimeters. And they tell me that dh dt is increasing, so I know it's going to be a positive 5 centimeters per minute. Let me just make that a little bit more clear. That is plus 5 centimeters per minute. Okay, so we've got our diagram labeled with the information. Now let's go ahead and write out our area equation. So area of a triangle equals 1/2 base times height. Okay, so I notice one thing before I get started is that I have a constant in the front. And so if I want to take a derivative, I can use the idea of a constant multiple. And because it's b times h, I'm going to also need to use the product rule. Okay, so the derivative of a is going to be dA dt because the area of the triangle is changing over time. I'm going to keep the 1/2 out in the front, and off to the side, let me set up my product rule for b times h. So u equals b, which means du doesn't equal 1, it equals dB dt. And v equals h, and that means dv is not 1, but it's dh dt. Okay, so now let's plug these into the product rule. So I have u dv plus v du. And now I want to find my dA dt, or the change of the area over time. So let's fill in what we know. I have 1/2 out in the front because of the constant multiple. My base is 10 times the height is changing by a +5 plus the height is currently at 22 and the base is shrinking, so -1. Okay, 1/2 50 minus 22 is going to equal 1/2 times 28, which should give us 14 centimeters squared per minute. Okay? Now let's zoom out for a moment so you could see the whole problem. But then let's also talk about what this means. So what this is saying is at the moment when the height is 22 and the base is 10, okay? So at that very moment in time, if the base decreases by 1 centimeter and the height increases by 5 centimeters per minute, then together what happens is the area will increase by 14 centimeters per minute. All right, so we're going to stop part 3 right here. Come back for part 4 for even more examples. Thanks so much, folks.